Here we have a straightforward arc length. We want the arc length of f of x equal to x to the 3/2 from x equal 1 to x equal 2. All right, the formula for arc length requires f prime of x, so that's 3/2 x to the 1/2. And here's the formula. The arc length is equal to the integral from 1 to 2 in our case, square root 1 plus f prime of x squared dx. Okay, so we have the integral from 1 to 2, square root 1 plus, here's our f prime, 3/2 x to the 1/2 squared dx. Okay, so we get, just square that out, we have 1 plus 9/4 x dx. This is a simple u substitution. We'll put u equal to this linear expression, 1 plus 9/4 x, and du is equal to 9/4 dx. So 4/9 du is equal to dx. All right, let's do our substituting now. I'm going to just drop these x limits. All right, and here I have the square root. We'll put them back later when we switch back to x. So here we have the square root of u, and dx, that's 4/9 du. So we're just going to do a power rule. This is u to the 1/2. Add 1, we have u to the 3/2. Divide by 3/2 or multiply by 2/3. So there we have 8 over 27. And u is 1 plus 9/4 x. And now I'm putting the limits back. We're going to evaluate between 1 and 2. All right, so let's do that. Just substitute in 2 and substitute in 1. So we have 8 over 27. Substituting in 2, we have 1 plus, oops, let me put that 3/2 back here. I dropped that by mistake. Put that 3/2 back. So here we have, let's see, first x is equal to 2, so we have 18 over 4 to the 3/2 minus 8 over 27. And now substitute in 1, so we have 1 plus 9/4 to the 3/2. And we'll just leave it like that. This question is based on the second part of the fundamental theorem of calculus, and that basically says that if you take the derivative of the integral from a to x f of t dt, that's equal to f of x. So we're using this part, the second part of the fundamental theorem of calculus, together with the chain rule, because here we don't have x on top, we have 3x. All right, so to take the derivative, all we do is substitute in 3x right here. And then multiply by the derivative of 3x. So that's where the chain rule comes in. And that's it. If you want, you can multiply this, square this out, and here we have 9x squared. Okay, times 3. That's it. Here we have a parabola, and we want to find the vertex, focus, and directrix. So we'll put this in a standard form by completing the square. All right, so we write on the right-hand side, factor out the 8. just from the first two terms. We'll leave the plus 10 on the outside. And we're ready to complete the square here. Let's take half the middle term is 1, square it, so that's plus 1, and then we have to subtract 1 as well. There's our perfect square. So let's write this as x plus 1 squared. And just open up the parentheses, multiply through by 8. 8 times x plus 1 squared, then 8 times minus 1, so we have minus 8 plus 10. So that's y is equal to 8, x plus 1 squared plus 2. And what we're aiming for is to solve for that x plus 1 squared. So we'll start by subtracting 2. So we have y minus 2 is equal to 8, x plus 1 squared. Now divide both sides by 8. And we have 1/8 y minus 2 is equal to x plus 1 squared. Now this is standard form for a parabola. This is a parabola that faces up, and whatever lands in front of this set of parentheses is 4p, so 4p is equal to 1/8, or p divided both sides by 4 is 1/32. The vertex we have right here, the x-coordinate is minus 1 and the y-coordinate is 2. So let's answer what we were asked to find. The vertex is minus 1, 2. The focus is, to get the focus, we just add p onto the y-coordinate of the vertex, since this parabola is a up-down parabola, not a right-left. And the directrix is y is equal to this coordinate minus the minus p. And that's it. That's the end of the review. I'm going to be putting up one more video which will show you the method, or a method, for integrating rational functions of sine and cosine. One more type of substitution.